Welcome to my YouTube channel. I hope everyone doing great. So I'm here to share a new topic with all. So in this today video, I'm going to discuss and walk you through the demo, like how you can manage access permission in GCP, like the role binding, how to assign the roles to any IAM members like users or service contact groups in GCP in an automated way using the Terraform. So in our very first video, I have shown you like how you can assign the roles to the IAM members manually by logging into the Google Cloud Console and navigating to the IAM. From there, you were able to assign the permissions, right? But I thought like what is the most organizations follow and also like preferable way to manage access permission in GCP. So the best way and the best practice also to manage access permission, also to create resource in the cloud environment, we need to learn your Terraform so that you can write the configuration rail, what resource you needed, and then you can deploy that code in a cloud environment so that a resource will get provision. So I don't want to waste any time. Let's just before starting the demo, I just want to give you some it's about this Terraform, and then we can get into that lab session part. So the first slide is what is Terraform. The Terraform is an open source and infrastructure as a code tool by HashiCorp. So basically, the Terraform, it is an open source, which is like anyone can use it. So they can download it from that official website or from the HashiCorp, and they can install in the local machines. And it is free to use. There is no license required. So infrastructure as a code, it is like when the cloud in the cloud we say infrastructure like the resource. Like we need to provision a resource to host some application to store some data. So some some resource has to be provisioned, right? So the Terraform will provide you that flexibility, like you can write in a configuration file that resource which is required, and that you can use some commands like Terraform apply or Terraform plan to preview the resource, and then you can go with Terraform apply to provision the resource in Google Cloud. And just one more thing I need to add, like this Terraform code, like it is very, not as very hard way to learn it. Like it's not like other programming language. So it is easiest way you can learn it. And also there are so many so many information you will get from the official documents when you want to provisioning some resource. So you can refer that documents. There will be some mandatory field you need to provide. What are the field? It's not mandatory. They also provide the optional. So if it is really required for a requirement, we need to provide. Otherwise, not required. And also like the best thing, it's like it is a human readable format. So any from your team, anyone wants to do some deployment, so they can refer they can use the same code and do some modification. For example, they want to create a new VM instance, so they need to upgrade the VM instance. They need to do some modification in the code and do the deployment, and Terraform will take care. So we will see what are the key features that Terraform is offering in upcoming slide. So in the key feature of Terraform, the first point we could say that multi-cloud support. So basically Terraform is not only for the GCP, like only particular cloud we can use it. It's not like that. You can use it for AWS, GCP, Azure, or Oracle, or on-premise also. So it support like multi-cloud. So for this lab, we are going to I'm going to show it in a GCP only. And the second point is like a declarative syntax. So declarative syntax, like so you know that there will be imperative way and declarative way, right? So in the imperative way, what you can do first, the step needs to be you will provide the step, so each step by step this has to be executed. So but in a declarative way, what happened, like you just mention what resource you need to be created. Terraform will take care like what needs to be created first and what needs to be created. For example, in a VM there will be a zone will be there, type what a resource type, and public IP or everything will be provided, right? So Terraform will take care of everything. It give you the desired end result. So it will not, you not to worry about what needs to be executed first and what step by step process. You don't need to give this instruction at all. So there this is one of the benefit I would say, and the key feature I would say. And the third one is like state management. So that state management, it is very important thing in Terraform. So it is used to track the current state of your infrastructure. The state ensuring that Terraform knows what resource exists and what action to take during that Terraform apply command is applying. So in this video, like I'll show you that how the state files are creating in my local machine. I'll show you like what are the things. So before that, I just give you some background information why it is really need the state file when we are provisioning some resource in GCP, right? So the state file in Terraform, that state file name, it is stored as like terraform.tf state to store the information about the resource that has been provisioned, and the configuration and the metadata. So and the dependency and all the relationship with it, everything, it will be stored in the Terraform state. So why it is important to track the infrastructure to ensure your desired state match that actual state, the first important thing. And second thing, like detect changes, addition or deletion. So if in your code, like you did some modification, like you want to upgrade any already created resource, or you want to create a new resource in the same configuration file, you do this modification, means the Terraform will detect and it will do that modification. For example, you have a new block in the existing configuration, you want to create a new resource, you added the block. So Terraform will not delete the existing resource, it only create the new resource, because Terraform will compare it with the state file and it knows like this is the new things has been there and it has to be created. And the important thing, it we can call it as like an incremental update, preventing recreation of the existing resource, right? And the final thing, like dependency management, so handle resource dependency automatically. So we can say like Terraform, it's suppose you're creating an VM instance, right? So that VM instance needed some dependency like network and also subnets to create a VM instance. So without network subnet, VMs are not able to create it. So when you written a code in a way that Terraform to create a VM instance, there will be a separate resource block which you use for the compute instance, and also with separate block for a network and for the subnet also, right? So Terraform knows for to create a virtual network, what are the things it is dependent on that. So first it will go and create that network, and it will create that subnet, and then it will create that VM instance, so that it will make sure that what desired state is looking for, it will be achieved, and it will take care all the dependency. But you need to mention the dependency, otherwise like you will get an error there. And the last slide, I mean, come to the last slide, like Terraform, how it works. So when you writing some code, I mean, configuration file, you need to keep in mind what are the things you need to follow, right? This is how it works in Terraform. So the first you need to write. So first you need to understand what are the resources required, what are the configuration that is required. So you need to write a code in by referring the official document, you can get the blocks, but you need to write the code in a way that what configuration it's required for your requirement. Second thing, once you did the configuration, and you need to do the plan. So in the Terraform plan command, you get to know that whether the resource creating exactly as you planned. So it's like a preview, and you can see like how many resources are creating, what is the configuration it has been creating, and everything. Once you get to validate all these things, you are I mean, you are confident with that, you can go ahead with the provisioning part. Just you can go with the Terraform apply. That's Terraform apply commands. What will happen, like it will provision the resource in the cloud environment. In our case, like it will provision the this in this video we are going to provisioning access, right? So it will provision the access in GCP, and you need to, it will ask for some prompt for some approval, like you need to provide us. So to like we can use like auto approve with it, so that Terraform will automatically approve the Terraform apply, and it will get provision in the CI/CD pipeline. Like there will be no human intervention while provisioning it, right? So there these things will be used, and Terra and destroy. So destroy, it is like once all the things has been created and completed, so you want to delete those resources which is created. So you don't want to go manually and delete all these things. So what are the configuration I mean resources which you described in your Terraform, the state versus matching it in cloud environment, right? So when you done that Terraform destroy, that resource will get deleted, and also Terraform know your dependency also. Before getting deleting this resource, what resource I need to delete first, so in order to delete this. So this is here also, like dependency management also will comes up in deleting, I mean in the strike command also. And that's it. I just want to give some overall information about this Terraform, and I don't want to waste your time, so we can get started with the lab here. Okay, so in this lab we are going to see the local, I'm going to explain the code here. The codes we are going to use it, and from the local machine I'm going to provisioning that access provisioning in GCP. So how we can achieve it? There are three different files, right? That main.tf and variable.tf and terraform.tf files. So let me explain all the files one by one here. So we can get into the main, first we can get into the main.tf. So main.tf, you can see the first thing which you can see, the block is called provider. So you can keep this provider block in a separator of file or any file. So one, you need to provide this, it's mandated to provide the this block. Why it does means like Terraform has to know like which it wants to communicate to the which provider. So there will be a supporting multiple environment, right, like a AWS, Azure, GCP, but we are working with GCP so that Terraform understand, okay, I'm just working with the GCP provider. So you need to this block you can take it from that official document also. There is a they are also having in detail. So what are the details we need to pass with that provider means the credential, project, region and zone. So the project, like we need to provide the project ID of that Google Flow project where we are going to provision the access to source, and the region, which region. So these are some mandatory things which we need to provide it. And credentials, like I just downloaded a service account keys. So let me show you like how we can download the navigator and use for the credentials here. So basically the credential is required to authenticate the Terraform to the GCP, right? And also it needs to have some valid permission, so then only that the Terraform can provision the resource. Let me log into the IAM here. So in the IAM console, right, if you see there is a tab called service accounts, right? In this service account, I'm just going to use a service account. So this service account, I'm going to use it for the use as a credential in my Terraform. This credential, it is used to authenticate to the GCP, and also it needs to have some valid permission. Valid permission, it's valid, you can assign the rules there to provisioning any resource. So for example, you want to assign any permission, right? So they need to have like set IAM policy, resource manager project, set IAM policy permissions, right? So we need to find what rules are providing this permission, and from the least to privilege you can just assign that rule. But the lab purpose, I'm just going with the project IAM and admin rule here. First let me create like a service account. So for what reason I'm going to use it, so let me give it some meaningful name here. IAM provision. Okay, so this is a service account because I'm using the service account to provision my provision the access in GCP, right? Then let me give some description. So I'm just given the description used person uh, rules in GCP, and just no need to do anything. So is there required any level? Yeah. So either you can assign the role from here, or you can also create the service account first, and you can go to the IAM page. From there also you can assign the role. For this, like project, let me give IAM admin role. So if you see there are multiple roles, right? Just I'm going with the project time and role. So after the lab, I'm going to delete all those things. So no need to go with the least privilege for this video. But when you're working on it, just consider what is the least permission. I mean, that role have like only if you're going to same permission, just check and verify and refer the document, or if it is there is no least privilege, I mean only for the particular activity of performing, just go with the custom role. So you can, if you want to learn more about the custom role, please refer this link, the custom roles. So I do have that created video for it, and then just we can continue. So if you see here, I have created a service account. Let me show you in the IAM console. So as you can see, this is the IAM provisioning, right? So this is the account which we have created, and it's a project IAM admin role. So let me go to that service account and download the key for the particular service account. So as of now, there is a no keys be there. So let me download the keys now. Add key, create key, and you can create the key in JSON. That is also recommended. So you will download the key, right? So I do have multiple keys. Okay, so I'm just pasting this key here. So let me see that path of the key. So this is a part where I have copied my code here. I mean downloaded my key, service account keys here. So I'm just going to copy this path here. So just keep in mind, when you're based on your mission, there will be some format will be there. So here, like I'm working on Windows mission, so I just going to provide a // here, so that only the path will be accepted. So it's a double. So if you see, this is how you can provide the path, and everything is looks fine. So let me try to explain here what are the codes here. As I said earlier, provider block you have to provide which provider you're using in a Terraform Google Cloud and the credential. And here, like I just mentioned, file and var.credential. So before this going to code, I'll just explain the variable.tf and terraform.tf files. So the variable.tf is like a variable where you want to declare the variable. So what are the variable? We are using it in a Terraform main.tf, right? So that variable, so for example, var.credentials is there, right? So this is the variable. So for this variable, we have stored in a values in a Terraform tf, right? So that value has been stored it here. So you can see here Google credential. But in order to use a variable in main.tf, we need to declare the variable in main.tf file. So this is how you need to consider, know about when you declare the variable. First, see the project ID. So the project ID, I'm going to make it as a variable so that I don't want to pass that value again and again Terraform. So I just mentioned that variable name whenever it's required in our code. So this is variable, and I need to provide the variable name and the description. So what is the description? If you need, you can provide, and type. So the type is like this is string I'm just providing. And second thing, you can see it like member one, member two, right? In the member one, this is member one which I'm using like to assign some roles to IAM members. Okay, for example, there will be GCP video having a multiple roles, right? So if you go and navigate to the main.tf file, so if you see it here, I just having a three resource block for different roles. One is like roles.viewer and roles.editor and roles.compute administrator. So in order to manage that IAM members separately, for example, the viewer role having the list of IAM members, right? So I've just mentioned it here. You can see the variable name like var.members one. So in that var.members one, that variable, I just mentioned list. So list means I can mention n number of user there. A number of principals there, either like a service account user or AD group, right? So for that, to make it separate this role, that IAM members for the IAM viewer role and editor role or compute admin role, I'm just creating that member list, a variable to declare all these values here. So the member one having only one user and member two having only one user. So I'm just given like a list, so you can add multiple user also there. For lab purpose, we are going to assign the permission to user only. That's what I just mentioned, user detail. So the main.tf. In that main.tf, this is the resource block, right? In this resource block, to assign that IAM roles to any IAM members, to any principals, right? There are a couple of ways, but one is, this is a recommended way from that documentation. So to know about what is the document, right? So let me navigate and show you this here. So this is your block, right? In that way, see, this is the document, official document, IAM policy for projects. So four different resources help you manage IAM policy. So there are like four different ways, right? But we are using this policy like a project IAM member. So this one is recommended also, non-authoritative update. So only what you are mentioning it in your code, that only that thing will happen. So what are things some manually edited in environment, that will not have any effect because of this. So you can read this document and check like what is very suitable for your what use case suitable for your organization, so that you can use it. Yeah, for each. So as I said, like there will be not only one IAM members are there will be multiple principles, like there will be more than one users or more than one service account or more than one groups needed the same roles, right? So you can define that n number of users in that member one in the terraform.tf files, and then project ID, in which project you want this role has to be provisioned and what role, and each value. So it will get that value from each one, and it will do that. It's like for each loop only. So we'll go and what are the IMMs, I'll go and provision for them, all of them. And the same way, like we copied and pasted here, but we just passing the member to different IAM members here, and the roles like editor, and the same thing which you're going to do. So this is all about the main.tf and terraform.tf. I'm just declare the values here, so nothing is there, and I'm declare the variables here. This is all things here. So let me go and just run that command here. The first thing when you working on Terraform, so let me, once all the code is ready, so first we need to run that Terraform init, right? So this will use to see here the provider which you have mentioned it in main.tf, right? Yeah, so if you see the provider block, in this provider block we have mentioned in Google, right? So the plugin, so it will initialize the provider plugin, find the latest version for the traffic of Google and all the dependencies which is required in order that Terraform to access the Google. So it will, all these things it will download it automatically. So you can see here that things which is already provided, everything it's been there, came up with it. So let me run Terraform plan first. So Terraform plan. So I said like it will give you the preview. It will not create anything in Google Cloud. It just give you preview. So in those things, what are the things it going to happen here? So here Terraform use that selected provider to generate the following executed plan, and our resources are indicated of the following step. Terraform will perform the following action. So you can see this is the fun action. So that IAM members here, that IAM members which is taken from that file, right? So will be created, and the resource editor IAM binding. So in that editor IAM binding, who will get it? The member. This is the member project value, and the roles. This is the same way it is goes for instance. So this is the same way. What are the values passing it here? And the same way it is goes for viewer roles. So this is how that a plan you can go and preview before getting to apply. So this is what I'm exactly want to achieve it, and this is what it showing it in preview. So Terraform apply. So I'm not going to provide auto approve, just I'm going to show in the lab propose. Like if any error, like any permission issues it's having with the credentials, means in this time it will throw an error, because we already given that project IAM admin, or I guess it will not throw an error. If it is throw error also, we can get it resolved, no problem. So you can see it here. It will asking for the enter a value, right? So it prompting some value. So once you need to provide yes to accept or approve. So let me just run it, and I'll just destroy it, and I'll show you in console, and again I'll do all these things again. So if you see it here, the three resource has been added here.